let us look at one example. Now we have one graph, v versus time, velocity versus time. Look at this graph. And then you need to calculate the acceleration over OP, acceleration here, PQ and QR. And then you need to find what is the displacement of the object and average velocity. So let us look at the first one. What is the acceleration over OPs? As we have discussed earlier, velocity for acceleration for a VT graph is the gradient of the graph. So for OP, you need to find what is the gradient here. So 10 minus 0 over 4 minus 0 comes from here. Okay, and then look at the unit, meter per second, and divide by second, then you have 2.5 meter per second squared. You can pause any part of the video so that you can look at it carefully. And then PQ, if PQ is 0, okay, because it is flat line, so it is the gradient is 0. And QR, this one, you can see here, when you look at the line itself, you will notice that it has a negative gradient. So when you calculate, you can substitute your number into the formula, then you get negative number here, negative 5 meter per second. And then what is the displacement for this graph? As we have learned earlier, for VT graph, the displacement is represented by the area under the graph. So you find for each part of the graph, you have 3 parts here. So for the first one, this one, this one, here is the calculation. And then this one, here's the calculation, and here's the calculation. So when you add all the numbers here, you get 70. And then average velocity, here's the formula. This total displacement over total time. So you have got 70 over here. So you put here 70 divided by 10. 10 comes from total time here. So the answer is 7 per meter second. And I have another question here. I want you to draw equivalent AT graph. Actually, we have calculated here. This is 2.5 meter per second. So you already know the acceleration is 2.5. So draw a straight line like this, and here is 2.5. And then for the second part here, PQ. For PQ, you already know that the acceleration is 0, so it should be here. Okay, should be exactly on this line. And then last one, for this part, the acceleration is negative 5 meter per second squared, so it should be somewhere here. This is negative 5. Okay, that's how you answer the question.